Good evening, millennials. Today we'll be looking at another LeetCode problem often asked in FAANG companies such as Microsoft and Amazon. So this is the 240th problem in the LeetCode website, Search 2D Matrix Part 2. So let's read the question. Write an efficient algorithm that searches for a value target in an M into an integer matrix. The matrix has the following properties. Integers in each row are sorted in ascending order from left to right. Okay, so this is sorted in ascending order from left to right. Integers in each column are sorted in ascending order from top to bottom. Okay, so we are given a matrix and a target, and we have to output true or false if it exists in the matrix. So as you can see, 5 exists in this matrix and we have to return true or false. Similarly, we search for another target in this 20 which is not there in this matrix, so we return false. So let's look at the constraints. M is the matrix.length and N is the matrix.i.length. So basically these are the number of rows and number of columns, and it's given that the number of rows and of columns is between 1 to 300. And the values of each element of the matrix is between 10 power minus 9 and 10 power 9, minus 10 power 9 and 10 power 9. And this is the important condition. All the integers in each row are sorted in ascending order in the input test case, and below that all the integers in each column are sorted in ascending order, as you can see. And the target, which is the number given, is also between minus 10 power 9 and 10 power 9. So first, let's intuitively try to think about the brute force method. So if you need more time to understand this question, please pause the video and read it. But I'll be discussing the brute force method followed by the efficient approach. So as you can see, the brute force approach would be just to traverse through both the rows and columns and then search for the element, but that would be an order of n square algorithm, and hence it's not efficient. So let's think of a more efficient way. We are given the information that all the integers in each row are sorted in ascending order in each row and in each column. Therefore, we have an intrinsic clue that when an array is sorted in ascending or descending order, we can search for an element using binary search. Here, since we know that an element is we know that each row and each column is sorted in ascending and descending order, we can try to binary search in this 2D matrix. So in a 1D array, when we try to binary search, we move in only one direction. But since this is a 2D array, we need to move in two directions when we do the binary search. So we can't start from 0, 0, as this is only sorted in one way, that is from left to right. Also, like when an element is greater, we won't know whether to move towards the right or towards down. So the logical solution here is to start from 0, n minus 1, where that is the last element of the first row. Because if an element is larger than this element, we know we need to search the next row. But if an element is smaller than this element, we know that we need to search it in the same row or the previous columns. So that way we can binary search between the rows and columns. So I think that solution should fit in our time constraints when we need an efficient algorithm, and the time complexity of this would be maximum of n log m and m log n, where m and n are the rows and columns respectively. Okay, let's try to code it. So first let me try to find the row. So row will be matrix dot size, and then column would be matrix of 0 dot size. Since it's given there'll be at least one row, I'm assuming it as matrix of 0 dot size. And then I have two variables which I will use to traverse, which is I for rows, and because we have to start in the first row, and the first will be col minus 1, because we'll be starting in the first row and last column, and an assignment takes place from left to right in C++. Okay, now let's look at the base conditions. If target less than matrix of 0 0, we know that this element won't exist in it because it's lesser than the least element, or target greater than matrix of row minus 1 and col minus 1. Then also we know that this element is the target element that we are trying to search in the studio array is greater than the maximum element in the studio array. So in this case we return false. Do remember that we are following a zero based array approach, so that's why row minus 1 and col minus 1. So else we need to search for the array. So while I is less than row, which is the maximum possible, and j is greater than or equal to 0, which is the first column, if we find the element, that is if target, which is the element we are searching, equal to matrix of ij, then we return true because we have found the element. So I just return true because the return type is bool. Else if the target, or we can write it as this, matrix of ij, if the current element is greater than the target, the current element that we are searching, if it's greater than the target, which means we have to search for a lesser element, therefore we have to reduce our column, else we have to increase our row. And at last, if we haven't found the element even after that, we just return a false. I think this should work. The logical binary search we have discussed. Let me just run the code once. Yeah, true. So take this example of 5. I start from 15, and since 15 is not equal to this matrix of ij, these won't hold true because the target 5 is not less than 1 and target 5 is not greater than 30. So it'll go here. So target is not equal to 15. So since 15 is greater than target, we go here 11. We do j minus minus. Similarly, from 11 we go to 7, and from 7 we go to 4, and at last from 4 we go to 5, and when we find it we return true. I think this should work. Yeah, and it's a success. So I've just run a couple of times to take care of cases. Please note that initially there were some problems in the test cases which I reported to LeetCode, where n and m were given 0 in the test cases, so that's why I've run it a few times. So that is the basic and the most shortest solution for this using binary search. If you have any questions, please leave it down in the comments, and if you have any feedback for us, or if you can find a shorter way to solve this, please leave it down in the comments and we'll be happy to post it. Thank you.